Hey math kids, today we're going to talk about the area above a curve, and this time we are given y equals x squared minus 2x, and the x-axis. So we want to find the area bounded by those two. So this is a parabola, and so what we want to do is we want to find where it crosses the x-axis. So we set this equal to 0, and we factor out in x. That leaves x minus 2. So we get x equals 0, x minus 2 equals 0, and that leaves us with x equals 0 and x equals 2. So these are the two places. So if we were to graph this without worrying about too many of the details, it's going to cross like that, and then we see that it is below the curve. And to compensate for that, we're going to put a negative sign out in front of our integral, and we use our x values from 0 to 2, and then we write our function in there. Okay, and then from here on out, it's just the same as what we did on the previous video. So we get x to the 3 over 3 minus 2x squared divided by 2. Evaluate that from 0 to 2, and then we have our negative sign out in front. So I want to do a couple things. I want to cancel this, and then I want to distribute my negative. Okay, now if I plug in a 2, I get negative, and then 2 cubed over 3 plus 2 squared. And then we subtract that and plug in zeros. If I plug in a 0 here, it goes away. Plug in a 0 here, it goes away. 0 plus 0 is just 0. So really, none of this matters on this problem. Okay, this is going to give me negative 8/3 plus 4. And so I'm going to think of the 4 like 12 over 3. And then I add those together and I get 4/3. So the area under the curve right here is 4/3 units squared. Okay. This next one's going to have some crazy simplification. So let's see, plus 2 x squared minus 3x. Okay. And the x-axis. Okay, so this is kind of the same thing. We want to set this equal to 0 to see where it crosses and to get a rough idea of what it looks like. So x, taking out an x from everything. And then we can t-factor that. We're going to give that a negative, and so we have our original x on the outside, x minus 1, and then x plus 3, which are going to give me 0, 1, and negative 3, respectively, if I set each of those equal to 0. Okay, so if we draw a quick graph, we're going to cross at 0, at 1, and at negative 3. Now, because this is the leading coefficient is positive, and it's a third degree, it's going to go something like this. And so we have an area above the curve as well as an area below the curve. So let me do those different colors actually. That one's going to be blue. Okay, so the area represented by the red is going to be from negative 3 to 0, and we're going to just plug in our function. So x to the third plus 2x squared minus 3x dx. And then the area represented by the blue is the same integral, just different different limits of an integration, and we want to make it negative, and that's going to be x cubed is 2x squared minus 3x. Okay. So we're just going to take the antiderivative of both of these. So we get x to the 4th over 4, and then we get plus x cubed, and then 2/3 minus 3x squared, and that's over 2. And then this will be exactly the same thing, just with different limits. And so it's x to the 4th over 4 plus 2x to the 3rd over 3 minus 3/2 x squared from 0 to 1. All right, so I'm going to scroll past that. Okay, so we're going to plug in a 0 here, here, and here, so everything goes away. Then we subtract when we plug in a -3. And when we do that, it's going to be -45/4. Okay, I'm not going to go through that entire thing just because that's not really the purpose of the video. Feel free to even just plug it in a calculator and get a decimal that's equivalent to that. Okay, now this one, I plug in a 1, and when I do that, I end up getting -7/12. And then I subtract that when I plug in a 0, and just like over there, it's a 0. Okay? So right here we have negative, negative, so that becomes 45/4. Right here, this doesn't really matter, and we have negative, negative again, so we have 7/12. Okay, I can multiply this by 3 over 3. So 45 would be 135 over 12 plus 7 over 12. And if we add those together, we get 142 over 12. Those are both divisible by 2. So we get 71 over 6. And yeah, that's similar to the answer that they get in the book, just written a little bit different. Okay, so once again, those are the units. I know I didn't go through the exact simplification to get to this, but remember, you just plug in a 0, get this, plug in a -3, get this. Plug in a 0, plug in a 1, get this, plug in a 0, get this, and then just be careful with your simplification. And like I said, on your homework, feel free to use a calculator. If you need more help, come to Math Lab. Until then, calculator.